Hi everyone, welcome back to Educlynk. So on the board, exercise 4. So exercise 4 is on Redox Equilibria. So all know Redox Equilibria was the last topic under the Equilibria. So in this case, I'm going to read the exercise for you guys. So consider the Redox half equation. So these are the Redox half equation. So the equation, we're having two of them. So here there is A and there's B. So as A saying, you have tin SN2 plus 2E minus E here. So giving what? SN solid. This physical state I'm giving a lot of fans. The physical states are very, very important here, especially at the level of the cell diagram. So some of you write their equation without putting the physical state, which is not correct. So the physical state is very, very important. So identify the strongest oxidizing agent. How do you know, or how do we identify the strongest oxidizing agent? How do we identify the strongest reducing agent? Because if you have a strongest oxidizing agent, you also have the strongest reducing agent. The strongest oxidizing agent, how do we identify it? Okay, firstly, the E theta value have been given to us. So here is the E theta. So here you have the E of the cell A is plus 1.2 volt. E of the second cell is plus 1.44 volt. Voilà. So these E values also are not given for fancy. It's going to help us to know which one is the strongest reducing agent, which one is the strongest oxidizing agent. So the strongest reducing agent comes from the half cell with the highest E theta value, or the highest electrode potential or standard electrode potential. So we compare these values. Here we have 1.2 volt, here we have 1.44 volt. In this case, the strongest oxidizing agent will come from this half cell. So then I was confused. There's SN solid and there's SN2. Which one are we going to choose also? So that's the dilemma. But here we are going to choose the oxidizing agent is choosing from the left. So our oxidizing agent here is ion 3. So here we have our oxidizing agent ion 3. So it's ion 3 plus, not ion 2. We choose the agent or the species on the left for the oxidizing agent. For the reducing agent, we choose that species on the right. So be very, very careful. If we were asked, because in this question we have just been asked to identify the strongest oxidizing agent. Imagine in another question they ask you, identify the strongest reducing agent. The answer in this case will be what? The answer will be SN solid. The reducing agent comes from the half cell with lowest E theta value. So the lowest E theta value is plus 1.2 volt. That's where the reducing agent will come. But when you see now, you're having two guys, you have SN solid and SN2 plus. So which one are you going to choose? You are choosing SN solid because I told you guys that the reducing agent is red on the left, on the right, sorry. So you read on the right, the reducing agent, the oxidizing agent you read on the left. Take note. That is very important. So Roman 2 now is to do what? Calculate the cell EMF. There are many formulae. Some books. So I'm going to give you two. You choose yours. So E of the cell is E of the right hand side minus E of the left hand side. For the moment, it's quite simple. It's quite very simple, but in university, you will see the nurse equation. The nurse equation is quite a bit complex. So this is the first formula. Let me give you the second one. E of the cell is E cathode minus E anode. The real problem is that, do you even know the anode? Do you know the cathode? The cathode is the more positive half cell. The anode is the less positive. So in this case now, that's notwithstanding, we're going to calculate the cell EMF. So it's a more positive value minus the less positive. So the more positive is 1.44 minus 1.2. So 1.44 minus 1.2. So that will give 0.42 volt positive. The plus sign is very, very, very important. Because some of you punch on a calculator, you will not see positive there, but the calculator, there's no positive there now. It's true the calculator will not give you an answer of positive, but when there's no sign means it's positive. So the cell EMF is a positive value. Positive value because it's a voltaic cell. A voltaic cell is actually a battery that will generate current electricity from chemical energy. So as the process of reduction and oxidation occur, this redox, this chemical energy is converted to electrical energy. So it's a voltaic cell. So it's doing work on a surrounding. That is why the sign is positive. You cannot construct a battery that instead of generating energy is going to consume energy. In that case, it's no more a voltaic cell. It's an electrolytic cell. So we'll now go to Roman 3. Roman 3 will be asked to write a cell diagram. To write a cell diagram is quite very simple. You start with the anode, you end with the cathode. At the anode, oxidation occur. At the cathode, reduction occur. The anode is the cell EMF is the half equation with the lowest E theta value. So we check the lowest E theta value. Obviously, it's a thin equation. So this is how we copy the anode. We copy the anode from the right to the left. So here we have Sn, solid, slash. I told you that when you put this slash means a change in state. We're moving from the solid state to the aqueous state. That is what I'm putting in the bar. So slash Sn 2 plus aqueous subbridge. This is only the anode I've written. Then after writing the anode, I write the cathode. So at the cathode, reduction occur, meaning at the cathode, the highest, the species with the highest oxidation state will reduce to a species with the lowest oxidation state. So the cathode is written in this direction. Write the cathode in this direction. So the cathode will be Fe3 plus aqueous. But yeah, are we going to put a slash or we are going to put a comma? Yes, very simple to know. The aqueous state means there's no change in physical states. All of them are in the aqueous states. Given that in the aqueous state, you are going to put a comma. So here we'll put a comma. Ion 2, aqueous. There's no solid. Given that there's no solid, we'll make platinum. Put platinum. Platinum is the inert electrode. So we'll put platinum here. Platinum solid. So that's the cell diagram. The last question was write a balanced equation. Very important. Write a balanced equation. So to write a balanced equation, you start with the anode. The balanced equation is gotten from this cell diagram. So the anode, Sn is oxidized to Sn2 plus 2E minus. I call it equation 1. At the cathode, reduction occur. Fe3 plus E minus give Fe2 plus. I call it equation 2. After writing the two equations, I balance the electrons. I realize that the electron in equation 1, there are two of them. In equation 2, we simply have a single electron. We multiply equation 2 by 2, equation 1 by 1. So equation 1 plus equation 2 equals. So we're adding the two equations. So first of all, you have two things that you have to do. You multiply, then you add. Why multiplying? Multiplying now is to balance the number of electrons. Here you have 2 electrons. Here you have just 1 electron. You multiply equation 2 by 2. But you multiply the whole equation before you add. Multiply means here you'll be having 2 electrons. Here now we'll be having 2 electrons because 1 times 2 is still 2. Add equation 1 to equation 2. We'll be having Sn plus 2 Fe 3 plus. That will give Sn 2 plus 2 plus 2 Fe 2 plus. So that's the balance equation. So let me tell you how I balance the equation. I am adding. So 1 times Sn is Sn. 2 times Fe3 is 2 Fe3. Giving Sn2 plus times 1. So it's Sn2 plus. This is the Sn2 plus here. Times 2. Fe2 plus times 2. We're having 2 Fe2 plus. Then, after balancing E, you will not just go and rest here and say, balance the equation. No. After balancing E, you are going to check and see if the equation is actually balanced. This is very important. So after balancing, you check your equation. You check it on the left and you check it on the right. Sn here is 1. There is also 1 Sn. It's okay. Ion. Yeah, you have 2 ions. You have 2 ions. So should we stop here? We shouldn't stop here because the charges. You have to check also the charges. So checking the charges now. You have 2 times 3, 6. You have 2 times 2 is 4 plus 2 is 6. The equation is perfectly balanced. So we'll arrive at the end of our class of today. So see you next class for the next chapter. That will be chapter 2. Chapter 2 is chemical kinetics or energetics. Chapter 3 is rates of reaction under physical chemistry. So thank you for watching. Stay tuned.